Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the solutions, detailed solutions of JEE Advanced 2025. So you can see that in this first question, there is a ring of radius capital R, and along the circumference of the ring, there is a spring whose axis is the circumference periphery of the ring, and the spring constant is K. Now one end of this spring is connected to this fixed support and the other end is connected to this disc. The radius of the disc is small r, and this disc is in equilibrium at this moment of time. Now to initiate a small SHM, let us displace this disc by an angle theta, and we have to find out the value of the omega, angular frequency of this disc. So for this, first of all, let us use the next page. So you can see that this is a ring and this is the spring. So let us displace the spring by an small angle theta. This is the small angle theta. Okay, so you can see that the value mg would be acting in the downward direction, and this small displacement x, theta is very small, therefore x will be equal to this radius. Now this radius is r minus r, and let us suppose that r minus r is equal to r dash. So x is equal to r dash, let us use it as r naught. So x is equal to r naught into theta. Okay, and spring force would be acting like that, kx, and this angle will be theta. So the component of mg along kx will be mg sine theta, and this component will be mg cos theta. Okay, so if we draw the disc separately, then we can say that on the disc a force is acting which is mg sine theta and kx, and friction will be acting in the backward direction because disc will roll like that, and the acceleration of disc will be a in this direction. So we can say that mg theta, for small angles we can write down sine theta as theta. So mg theta plus kx minus f barabar ma. This is the first equation, and the equation of torque can be written as F into R is equal to m r square by 2 into alpha. Now let us suppose that alpha 1 is the angular acceleration of the disc about its center. So alpha 1 will be equal to a by r. So F will be equal to m r by 2 into a by r. Cancelling r with r, F will be equal to m a by 2. Substituting this value in this equation, we can say that mg theta plus kx is equal to 3 by 2 ma, and the value of x is r naught theta. So mg plus k r naught, and theta is common, is equal to 3 by 2 ma. Okay, and a is the acceleration of the disc, center of the disc, like that. Now let us suppose the angular acceleration of the disc center about the center of the ring is alpha 2. So we know that alpha 2 barabar will be equal to a by r minus r, where r minus r is r naught. So we can substitute these values, and a is alpha 2 into r naught. So mg plus k r naught, into theta will be equal to 3 by 2 into m into a is alpha 2 r naught, and the value of alpha 2 will be omega square theta. So this is mg plus k r naught into theta is equal to 3 by 2 m into alpha 2 is omega square theta into r naught. So cancelling this theta with theta, so omega square will be equal to 2 by 3 m divided by r naught plus 2 by 3 k by m, and omega will be equal to under root of 2 by 3 m by r minus r plus 2 by 3 k by m. So you can see that the correct answer will be option A. I would rate this question as an average question, not a tough one. It is an average question. Now let us move on the next question. In this question, you can see that in an scattering experiment, a particle of mass 2m is moving with some finite velocity. Let's suppose it is u in this direction, and another particle which is at rest has a mass m, and after collision this 2m particle is deflected by an angle theta, and it is deflected by some angle which is not given in the question. So let us suppose it is alpha. So we have to find out the maximum possible value of theta, which is the scattering angle of 2m, if the collision is elastic collision. So what we'll do, we'll first of all conserve the momentum in x direction. So this is v1 and this is v2. So the first equation will be 2, in fact I'll write it down here, 2m. Let us write down with the another ink, this is right. So 2mu will be equal to mv1, in fact 2mv1 cos theta plus mv2 cos alpha. And if we simplify this equation further, it would be 2u minus 2v1 cos theta, and it would be equal to v2 cos alpha. This is the first equation. Now we know that in the y direction net momentum will be 0, because initial momentum in the y was also 0. Okay, so we can say that m, in fact this is 0, yeah. So 2m v1 sin theta will be equal to m v2 sin alpha, and v2 sin alpha will be equal to 2v1 sin theta. This is equation number 2. Let us square and add these two equations to eliminate alpha. So v2 square sin square alpha plus v1 square plus v2 square cos square alpha. So it would be equal to v2 square, and it would be 4v1 square sin square theta plus 4u square plus 4v1 square cos square theta minus 8uv1 cos theta. Okay, and we also know that kinetic energy is also conserved because collision is elastic. So therefore we can conserve the kinetic energy, and we can write down the equation as half into 2m u square, and that is equal to half into 2m v1 square plus half into m v2 square, cancelling half with half with half, m with m with m. So the equation, I'll write it down on the next page. So the equation will be 2u square minus 2v1 square is equal to v2 square. 2u square minus v1 square is equal to v2 square. And we will substitute this value in this equation. So by substituting this value, we can say that 2u square minus v1 square will be equal to 4v1 square sin square theta plus 4v1 square cos square theta. So this is 4v1 square plus 4u square. So it is 4v1 square plus 4u square, and this term will be 8u v1 cos theta. So this is minus 8u v1 cos theta. So let us make a quadratic equation in u. So it would be 2u square. We are cancelling this 2. Okay, so it would be u square plus 3v1 square minus 4 u v1 cos theta, and that is 0. So the value of u will be minus 4, in fact plus 4 into v1 cos theta plus minus under root b square, which is b square will be 16 v1 square cos square theta and plus 4ac minus 4 into 3 into v1 square divided by 2. So we know that u cannot be imaginary, so this the discriminant should be greater than or equal to 0. So 16 v1 square cos square theta should be either greater than or equal to 12 v1 square. Cancelling v1 square, cos square theta should be greater than or equal to 3 by 4 and cos theta should be greater than or equal to root 3 by 2. So theta should be less than or equal to pi by 6. So the maximum scattering angle will be pi by 6. Now let us move on the next question. In this question, you can see that there is a square loop which is initially placed on xz plane, and this loop is hinged on x-axis in such a way such that it is free to rotate about x-axis, but it cannot move. There is a time dependent magnetic field which is pointing towards k cap, and this is b naught cos omega t, and this loop is being rotated with an angular velocity of omega in the clockwise sense. So we know that the initial area vector of the loop will be like that, and the final area vector after rotation it would be like that. And if this angle is theta, then this will be theta. So a vector, area vector, will be equal to a cos theta, which is cos omega t I cap, minus a sin omega t k cap. Okay, and b will be b naught cos omega t k cap. Now we know that flux is equal to b dot a, and b dot a will be minus a into b naught into cos omega t sin omega t, and we can write it down as phi is equal to minus a b naught by 2 sin 2 omega t. Okay, and EMF is d phi by dt. So it would be equal to minus d phi by dt. So it would be equal to plus a b naught by 2 into 2 omega cos 2 omega t. So EMF will be a b naught omega cos 2 omega t. So you can see that EMF is a function of cos. So these options will be incorrect, and obviously you can see that the frequency of this EMF is 2 omega, and therefore the time period 2 omega will be equal to 2 pi by t. So t will be equal to pi by omega. So the time period will be pi by omega, as well as there will be a break in the graph. So this obviously the correct option will be A. but there will be a break in the graph in the middle section, because when this loop will complete the half rotation and when it will come back from the backward direction, or we can say that behind the xz plane, when it will rotate behind the xz plane, then in that region behind the xz plane there is no magnetic field. Hence we can say that the EMF generated in the loop will be 0 when it would be rotating behind the xz plane, and again when it would come in the positive x in the on the right side of the xz plane, then EMF will be induced. So the correct option will be option A. Now let's move on the next question. In this question you can see that this is a vernier caliper and this is the vernier scale, and the first figure shows the vernier scale when no measurement is done, and it clearly indicates that the 0 of vernier scale and 0 of main scale are exactly matching. So therefore the 0 error in the device, 0 error, will be 0. Okay, and you can see that there are 10 divisions on main scale which are equal to 1 centimeter. So we can say that 10 MSD are 1 centimeter. So 1 MSD will be equal to 1 mm. Okay, and we can also say that this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is 1, 2, 3, 4, 5, 6, 7. 7 MSD are exactly matching with 10 VSD. So 1 VSD will be equal to 7 by 10 MSD. Okay, and least count will be equal to 1 MSD minus 1 VSD. So least count will be equal to 1 MSD minus 1 VSD is 0.3 MSD, and 1 MSD is 1 mm, so least count will be equal to 0.3 mm. This is the least count, and when we see the scale during the measurement, then we can say that the MSR, main scale reading, is 1. MSR is 1 mm, and the CSR, in fact VSR, vernier scale reading, so it is 0 and 1. So VSR is 1 into least count, which is 0.3. So VSR is 0.3, and the measured value of the diameter will be 1.3 mm. Now in centimeters it would be 0.13 centimeters. So the correct answer will be C. Now we move on the next question. In this question you can see that there is a conducting square loop of side L by L and mass m and resistance R. This loop is being given a velocity of v naught in a uniform magnetic field B naught, which is pointing in the k cap, and it is starting from y is equal to 0. So we have given some velocity v naught to this loop initially, and we have to choose the correct option. So first of all, let us see the motion of the loop. We can see that at some time t, let's suppose loop has entered the magnetic field by a distance of x. Okay, and the flux linked with the loop will be b naught into, this is L, so this is Lx. So d phi by dt will be the EMF, and we are just concerned about the magnitude of EMF, so it would be d phi by dt, and it is b naught L, and dx by dt is v. So v is the velocity at any time t. So the EMF in the loop will be b naught LV, which we all know already, and the current flowing in the loop will be B naught LV by R. And due to this current, there will be a force acting on the section of the loop, this section in the backward direction, which would be retarding this loop, and this force will be ILB, where L is this length. So F will be equal to ILB. So F will be I is B naught LV by R, and this is LB. So F will be equal to B naught L square, B naught, in fact B naught square L square, and V by R, and F will be equal to ma, mass into acceleration, and this is B naught square L square V by R. Okay, and A can be written as dV by dt, minus of dV by dt, because this force is retarding this loop, so velocity will be slowing down. So it would be B naught square L square V by R, and we can say that dV by V will be equal to B naught square L square by mr with a negative sign, and this is dt. So integration of this term, and this is the k, this is the value of k. So we can say that the limit of velocity will be from v naught to v. So ln v by v naught will be equal to minus of, this is 0 set t, so it would be minus of kt. So v by v naught will be equal to e to the power minus kt. So v will be equal to v naught e to the power minus kt. This is the velocity, and this velocity is a exponential decaying one. So it would be decaying exponentially like this, starting from v naught like this. Okay, and the first option says that if velocity is this, then loop will stop before it enters completely in the magnetic field. So let us analyze this thing. So let us see that if we can write velocity as dx by dt. So it would be v naught e to the power minus kt. So dx will be equal to v naught e to the power minus kt dt, integrating both the sides, and limit of x would be from 0 to x and from 0 to t. So x will be equal to v naught by minus k e to the power minus kt, and the limit of the time will be from 0 to t. So x will be equal to v naught by k and 1 minus e to the power minus kt. Okay, this is x. So x is v naught by k and 1 minus e to the power minus kt. Okay, and if the value of v naught is 1.5 kl, so v naught is 1.5 kl, x will be equal to 1.5 L into 1 minus e to the power minus kt. Okay, and we know that obviously the loop will stop at t is equal to infinity. At t is equal to infinity, v will be 0. So at t is equal to infinity, x will be equal to 1.5 L. So we know that when this loop will completely enter the magnetic field, x will be equal to L, which is this length. This is a square loop obviously, so x will be L when it will enter completely the magnetic field, and this x is 1.5 L. So option A is incorrect. Okay, now when the loop will completely enter the region of the magnetic field, then net force acting on the loop will be 0. This is correct, because when the loop will completely enter the region of magnetic field, then the flux of the loop will become constant and the EMF will be 0 and net force acting on the loop will be 0. Now if for the C option, if V naught is equal to KL by 10 loop comes to rest in this time. So V0 is anything. If V0 is anything whatsoever be the value of V0, the loop will come to rest at t is equal to infinity only. Okay, so this is also a fact that if the loop will enter the magnetic field before coming to rest, then it will always keep on moving with the same constant speed inside the magnetic field. So C option is also incorrect. And if we check the D option, that if V0 is 3 KL, then complete loop enters the region of magnetic field in this time. So if V0 is 3 KL, if V0 is 3 KL, then X will be equal to 3L 1 minus e to the power minus KT. And when this loop will completely enter the magnetic field, X will be equal to L. So L will be equal to 3L 1 minus e to the power minus KT, and 1 by 3 will be equal to 1 minus e to the power minus KT. So e to the power minus KT will be equal to 2 by 3, and e to the power KT will be equal to 3 by 2, and T will be equal to 1 by K ln 3 by 2. So the correct answer will be B and D. Now we move on the next question. In this question, you can see that there is a strip whose length is 10.5 centimeters, breadth is 0.05 mm, and whose thickness is 6 micrometers. So we have to find out, we have to report the volume of the strip in proper significant figures. So we know that the volume of the strip will be length into breadth into thickness. So volume will be length, which is 10.5 into, now we have to find out the answer in centimeter cube only. So we can leave this in centimeters, into 0.05 mm. Now 1 mm is 10 to the power minus 1 centimeter, so this is 10 to the power minus 1, and 6 micrometers, so 6 into 10 to the power minus 6. Now this is micrometer, so it would be 10 to the power minus 6 meters, and in millimeter, it in centimeters, it would be 10 to the power minus 4 centimeters. So 10.5 into 0.05 into 6 is 3.15, and this is 10 to the power minus 5. And we know that the rules of multiplication in significant figure says that we have to report the final answer in that number of significant figures which is the least significant figures in the multiplied quantities. So the multiplied numbers are these three, and we know that the least number of significant figures, in this there are 3 significant figures, 3 SF. In this there are only 1 SF, and in this there are 2 SF. Okay, so the least number of significant figure is 1, so the answer will be reported in 1 significant figure by rounding off. So this will be 3 into 10 raised to power minus 5. So the correct answer will be option number D. Now we move on the next question. In this question you can see that there are 3 strings which are connected to each other, S1, S2 and S3, and the linear mass densities of all these 3 strings is different. The linear mass density of S1 is mu, the linear mass density of S2 is 4 mu, and the linear mass density of S3 is 16 mu. So a wave is generated from this end, and this wave is represented by this equation. So we have to choose the correct options. So when in the first case, when in the first option, when the wave will be reflected from point P for the first time, the reflected wave is represented by this equation where alpha 1 is a positive constant. So you can see that we have to remember three main things. First thing is the fact that when the wave will travel, this is a rarer medium and this is a denser medium. So we can say that wave is traveling from rarer to denser medium, and hence this end will be a fixed end. This will be a fixed end, because when wave travels from rarer medium to denser medium, then interface behaves like a fixed end. Okay, and therefore we can say that some of the part of the wave will be transmitted and some part of the wave would be reflected back. Now obviously the wave which is reflected back from this point, we can say that its amplitude will change, and therefore you can observe that in the reflected wave, in the incident wave, the amplitude was y0, and in the reflected wave amplitude is alpha 1 y0. So obviously for any value of alpha 1, this amplitude has changed. And the another important thing to remember is the fact that we know that when the wave is traveling from left side to right side, the sign of omega t and kx are different. But obviously we are talking about the reflected wave in this A option, so the sign of omega t and kx would be same, first of all. And as the wave is reflected from the fixed end, we can say that there would be a phase change of pi in the reflected wave. So we can say this A option is absolutely correct, as the wave mentioned in the A option is correctly matching the wave which should be the reflected wave. When the wave is transmitted from P for the first time, the transmitted wave is represented by this equation, where alpha 2 is a positive constant. Now when we are talking about the transmitted wave, the direction of incident and transmitted wave has not changed, and therefore we can say that the sign of omega t and kx would be different in the transmitted wave also, and the amplitude will also be different. But there is an important thing to remember, that when we are talking about the transmitted wave, so the transmitted wave is traveling in a denser medium, so k would be different, this k would change. So when k would change, so this wave could not be the correct one, because incident wave and transmitted wave could not have the same k. Now option C. In the option C, you can see that when the wave is reflected from Q for the first time, the reflected wave is represented by this equation, where alpha 3 is a positive constant. So when the wave is reflected from Q, so the reflected wave is going from right to left, so this could not be the correct one, because the sign of omega t and kx should be same when the wave is traveling from right to left. Now in the D option, you can see that when the wave is transmitted from Q for the first time, then the transmitted wave is represented by this equation. So first of all, we know that amplitude would change, so this is correct. The direction is same as that of the incident wave, so wave is still traveling in the direction from left to right. And the third and important thing is the fact that the speed will change, because mu is different, and k will also change. We know that v is equal to under root of t by mu. So v1 by v2 will be equal to k2 by k1, because we know that v is equal to omega by k, and this will be equal to under root of mu 2 by mu 1. So we can say that k2 by k1 will be equal to 4, because mu 2 by mu 1 is root 16, which is 4, and k2 will be 4k. So the propagation constant of the transmitted wave in this string will be 4 times. So D is also correct. So the correct options are A and D. Now we move on to the next question. In this question, you can see that there is a person which is sitting inside an elevator, and he performs weighing experiment with an object of mass 50 kg. So let us suppose that there is elevator and there is an object kept inside the elevator. The mass of the object is 50 kg, m is equal to 50 kg, and the elevator is performing SHM, and the displacement of the elevator y is 8 into 1 plus sine 2 pi t by t. Okay, and the velocity v is dy by dt. So it is 8 into 2 pi by t cos 2 pi t by t, and the acceleration a is dv by dt. So it is 8 into 4 pi square by t square, and there is a negative sign because differentiation of cos is minus sign, and this is sine 2 pi t by t. So if we talk about the maximum amplitude of acceleration, so it would be 16 pi square by t square, and the value of t is 40 pi, so this is 16 pi square by 1600. Okay, in fact this would be 32, sorry, so it would be 32, and this is 1600 pi square. So cancelling this, a max is 1 by 50. Okay, and at the negative extreme, let us draw the scenario that at minus a max is in the upward direction, therefore mg and pseudo force max will be acting in the downward direction. So this is weight w1, and at positive extreme plus a max is in the downward direction, so mg will be acting in the downward direction and pseudo force max will be acting in the upward direction. So the weight w2 at the top position will be mg minus max. So delta w, change in weight, will be equal to 2 max, and this is 2, m is 50, a max is 1 by 50. So the maximum variation is 2 in the weight, that is delta w. So the correct answer will be 2. Now we move on the next question. In this question you can see that there is a cube of unit volume, and that cube contains 35 into 10 raised to power 7 photons. So let us name it as n, and the frequency of each photon is 10 to the power 15 hertz. Let us name it as nu. Now we can imagine that the energy of all the photons is the average energy contained in an electromagnetic wave within the same volume, which is 1 meter cube, because it is given as unit volume. And we have to find out the amplitude of magnetic field of such electromagnetic wave. Now this is a very easy question. We can see that the total energy per unit volume, which is also called as energy density, is equal to h nu into n, where h nu is the energy of one photon and n is the total number of photons per unit volume. Okay, and this will be equal to half b naught square by mu naught. Okay, because the average energy contained in an electromagnetic wave is this. Okay, and b naught is therefore equal to under root of 2 mu naught into h nu n, and n is this, nu is this, h is this, and the value of mu naught is this. So we can substitute all these values, and b naught will be equal to 22.98 into 10 raised to power minus 9. So alpha will be equal to 22.98. This will be the correct answer. Okay, now we move on the next question. In this question you can see that there are two identical plates P and Q, and these plates are ideal black bodies, and these are kept in vacuum. The temperature of P is Tp and temperature of Q is Tq, and Tp is greater than Tq. Now the radiated power which is transferred from P to Q, this is the net power which is transferred from P to Q, it is W naught. And in the second figure you can see that two more plates identical to P and Q are introduced between P and Q, and the heat is exchanged only between the adjacent plates, which means that heat exchange is taking place between these two plates, between these two plates, and between these two plates. And it is given that assume that heat transfer takes place between adjacent plates, and the power transferred from P to Q in the steady state is Ws. So steady state means that each plate will have a constant temperature. Therefore, the amount of heat, net heat received by any plate will be directly transferred to the heat to the further neighboring plate. So we can say that the heat received by this plate 1 Ws is being transferred as it is to plate 2, and heat received by plate 2 is being transferred as it is to plate Q. So this is also Ws. Okay, so we can say that first of all W naught. So we know that power is sigma E A T to the power 4, and E is 1 because these are ideal black bodies, and A area is also 1 because the power transferred per unit area is mentioned in the question. So it will be W naught will be sigma Tp की power 4 minus Tq की power 4. This is the net power transferred between P and Q. Now Ws. So Ws in this case will be equal to sigma into Tp की power 4 minus T1 की power 4. Now Ws in the second case will be equal to sigma into T1 की power 4 minus T2 की power 4, and Ws for the plate 2 and Q will be equal to sigma into T2 की power 4 minus Tq की power 4. Now if we add these all three equations, this and this, then 3Ws will be equal to sigma Tp की power 4 minus Tq की power 4. Okay, and Ws will be equal to sigma Tp की power 4 minus Tq की power 4. Okay, and we have to find out W naught by Ws. So W naught by Ws will be this is divided by 3, so it would be 3. So the correct answer will be 3. Now we move on the next question. In this question, you can see that there is a solid glass sphere of refractive index root 3. The radius of a sphere is r, and this sphere has a air cavity inside it. The radius of air cavity is r by 2. A very thin glass layer is present at this point O, and inside this small cavity there is air filled. Now the refractive index of air is 1, and unpolarized unidirectional monochromatic light source S is emitting the light at this point. This light is reflected from this point, and then it is reflected from somewhere here, and then it enters this air cavity, and then it falls on point O. Now at point O, this light is reflected again, and the reflected light is 100% polarized, which means obviously that this light has is incident at point O at the polarizing angle. So we have to find out the value of sine theta. So first of all, let us draw the scenario. This is the case, and first of all let us trace the light. The light ray will travel like this, and then light ray, there will be a normal drawn at this point. Okay, and this angle will be theta, this will be theta, obviously, because this radius is r and this is also r. And now light is reflected from this point, it is incident at somewhere at this point, and if we draw a normal at this point, then normal to this surface will be like that. And then this light ray travels from this point to this point after refraction. So this is the scenario. Now you can see that if we connect these two, so now let us name the points. This point is A, B, C, and this is D. Now this angle will be the polarizing angle, and polarizing angle is tan inverse mu, and IP will be tan inverse mu is root 3. So polarizing angle IP will be 60 degree. This is 60 degree. Okay, and this angle will be 60. Now this is radius r by 2, this is r by 2. So this angle will again be 60 degree. Okay, and now if we find out this I by using Snell's law, then we can say that root 3 sine I will be equal to 1 sine 60. So root 3 sine I will be sine 60. Sine 60 is root 3 by 2. So I will be equal to 30 degree. So this is I, this is 30 degree. And if this angle, obviously this angle will be 60 again, this will be 120, and as this angle and this angle will be equal, because this is r by 2, this is r by 2, so these two angles will be 30 30, and the length of side BC will be, this is r by 2 and this is 90 degree, so this half length will be r by 2 cos 30, so BC will be r cos 30. Cos 30 is root 3 by 2, so this is r into root 3 by 2. This is BC. Okay, now this angle will be 120 and this angle will be theta. Now we apply sine law in this triangle BCD. So according to sine law, sine theta upon this length BC will be equal to this sine 120 upon this length BD, and this length BD will be R, obviously, radius of the bigger sphere. Now sine theta will be equal to sine 120. Now sine 120 is root 3 r by 2. So this is root 3 by 2 into BC. BC will be root 3 by 2. I have already cancelled r with r. So sine theta will be equal to 3 by 4. So the value of sine theta will be equal to 0.75. So the correct answer of this question is 0.75. Now we move on the next question. In this question, you can see that a single slit diffraction experiment is being performed to determine the slit width using this equation: B d by d is equal to m lambda, where B is the slit width, D is the shortest distance between the slit and the screen, and D is the distance between mth diffraction maximum and central maxima. Okay, and lambda is the wavelength. Now it is given in the question that the devices which are used for measuring the value of D and D has a least count of 1 centimeter which is measured which is measuring D, and has a least count of 1 mm for the device which is measuring small d. The value of lambda and m are precisely known, as precisely means ki there is no error in the measurement of lambda, as well as there is no error in the measurement of this small m. So the value of lambda is this without any error, and value of m is this. The absolute error in the measurement of b should be. So what we are doing in this case, that b d by d is equal to m lambda first of all, and small b will be equal to m lambda capital D by small d. Now you must have studied, and I have also taught in errors, that we should differentiate the equation upfront. But in this case, that method of differentiation is not valid, because you can see that the error in measurement of small d is 1 mm, because we know that in the case when the errors in measurement of any quantity are not mentioned, then we always assume the least count of the devices as the maximum possible error in the device in that measurement value. So this error is 1 mm for measurement of D, and the value of D is 5 mm. So there is a, you can see that if error is 1 mm and true value is 5 mm, then error is 20% of the true value. So this is a huge amount of error, and therefore this method of differentiation is not valid in this case. So we will use the manual method. I'll tell you that what is the manual method. That let's suppose a resistance of any conductor is rho L by A. Okay, and we are being given that length has an error of 50%. So we could not differentiate, and we could not use this 50% in that differentiation method, because that method of differentiation is not valid in the case when the error is 50%. In fact, you all know that we always use that method for errors below 10%, single digit errors, percentage errors. Okay, so this, for this amount of error, that differentiation method is not valid. So what we'll do, we'll write down the initial value of resistance, and then we will add up the length, and we will add the 50% of length. So the new length will be 3 by 2L, and then we will use the new value of resistance to calculate the error in resistance. So this is the case. So we will again do this thing here. So you can see that if we substitute the value of m, lambda and d, then m is 3, lambda is 600 nanometer, which is 10 to the power minus 9, and capital D is 1 mm, 1 meter, and small d is given as 5 mm. So this is 5 into 10 raised to the power minus 3. So B is equal to 3.6 into 10 to the power minus 4 meters, and if we have to report the answer in micrometers, we can take the B in micrometer, which would be 360 micrometers. Now we'll find out the maximum value of D. So we know that D will be maximum when capital D will be maximum and small d will be minimum. So m is 5, in fact m is 3, and lambda is 600 nanometer, 10 to the power minus 9, and this d max will be 1 plus 0.01, so it would be 1.01 meter, and divided by d minimum would be 4 mm, 4 into 10 to the power minus 3. So this would be 18.18 into 10 to the power minus 4 divided by 4, and this would be 4.54 into 10 to the power minus 4. So it is 454 micrometers, and therefore the error in B, dB, will be 454 minus 360, which is 94 micrometers. So the answer of this problem should be 94 micrometers, and if you will use the method of differentiation, then it would be around 74 micrometers. So I think that method is absolutely wrong, and JEE also agrees with this answer. So this should be the correct answer. Now we move on the next question. In this question you can see that there is an electron which is revolving in an hydrogen-like orbit in the hydrogen-like atom around its nucleus in an orbit of n is equal to 3. The atomic number of the atom is Z, and the absolute temperature is T. There is a neutron which has a thermal kinetic energy of kB into T, and the de Broglie wavelength of this neutron and de Broglie wavelength of that revolving electron is exactly same. So we have to find out the value of alpha, where alpha is any number in this expression of temperature. So we know that mvr is equal to nh upon 2 pi. This is the angular momentum of the revolving electron, and mv will be equal to nh upon 2 pi r. And r is a naught into n square by z. Okay, we know that by hydrogen Bohr's model of hydrogen atom. And mv is the momentum, and it would be nh by 2 pi a naught into n square by z. So mv will be equal to nhz. In fact, n would be cancelled in the denominator, so hz upon 2 pi a naught n. This is mv. And the momentum p will be h upon mv, and p will be equal to h upon mv is hz upon 2 pi a naught n. Cancelling h with h, p is equal to 2 pi a naught n by z. In fact, this is the de Broglie wavelength. Momentum is mv, so this is the de Broglie wavelength of electron, and this is again de Broglie wavelength. And the de Broglie wavelength of neutron, which is having this energy, will be h upon under root 2 mk. Okay, so lambda n will be equal to h upon under root of 2m into kinetic energy is kbt. So these two are equal, so 2 pi a naught n by z is equal to h upon under root of 2m kbt. So this is 4 pi square a naught square n square by z square is equal to h square by 2m into kbt, and t will be equal to h square z square upon this is 8 pi square a naught square kb. Now obviously n square is 9 because n is 3, so alpha will be equal to 8 into 9, which is 72. So the correct answer of this question would be 72. Now we move on the next question. In this question you can see that the column 1 represents some orientations of two dipoles, and column 2 represents the net electric field at the given point. So we have to choose the correct option. So we can see easily that in these kind of questions we don't have to check all the 4 options. In fact, we can eliminate any 2 of them. So we will use this trick in this question also. we know that there are 4 options and P is matched with 2, 4 and 3. So we just need to find out the correct matching of P first of all. So we know that this point X is on equatorial axis for both of these dipoles, and therefore the electric field at this point X will be in the downward direction due to both of them, and E would be equal to 2 kp by, in fact, kp by r cube due to one and kp by r cube due to another. So it would be 2 kp by r cube and direction will be minus j cap. So electric field will be represented by option number 2. So P matches with 2. So the first option, we know that A and B will be incorrect. Now we know that this Q option is matching with 1 in both of the options, which are probable ones, and therefore we have to find out the matching of R. So R option is this one, and we know that for this dipole, for the first dipole, point X is on equatorial axis, and therefore the electric field on this point X will be in the downward direction, which is kp by r cube, and X is on the axial point for this dipole, so electric field will be in this direction, 2 kp by r cube. So the correct matching will be 2 kp by r cube I cap and minus kp by r cube j cap. So correct matching of R will be option 4th. So we can say that the correct answer will be C. Now let's move on the next question. In this question you can see that there is a electrical circuit which has some impedance, and the voltage connected across this circuit is this one. So we have to choose the correct matching of list 1, which has some circuits, and list 2 has their graph of currents with time. So first of all, let us see the options. So we know that in option A, B, C, D, the only 2 matchings of P is 3 and 1. So let us first of all verify the matching of 3, in fact P. So we know that in option P there is only resistance, and therefore we can say that current and voltage would be in the same phase, and the peak value of current will be equal to 300 upon 30, that is 10. So I will be equal to 10 sine 400t. Okay, so the correct option of P will be 3. So B and D are incorrect. Now we need to check option Q. In option Q you can see that XL is 100 into 10 to the power minus 3 into omega, which is 400, so it is 40, and R is 30 and Z is 50. So the peak value of the current will be equal to 300 by 50, so it is 6. And if we draw the phasor diagram, so in phasor diagram, in series circuit, current will be on the x-axis, VR is on the x-axis, and VL will be on the y-axis, and this will be R and this will be XL, and this is Z. This angle is phi, and therefore the voltage will be making an angle of phi with the current. So tan phi will be equal to XL by R, and tan phi will be equal to XL is 40, R is 30, so it is phi is 53. So net voltage will be ahead of current by 53 and current will be behind. So I will be I naught, which is 6 sine 400t minus 53 degree. So you can see that this graph would be of sine and the phase would be negative, and the peak value of current would be around 5, which is also given in the question. So you can see that the correct matching of this option Q will be 5. So the correct answer will be A. Okay, now we move on the next question. in this question you can see that list 1 shows the functional dependencies of energy of different phenomena on atomic numbers, and list 2 shows those phenomena. So again we will check the P option and we will see that there are 3 matchings of P, 4, 5 and 3. So first of all we see that E is proportional to Z square. So we all know that in hydrogen atom or hydrogen like atoms, energy is minus 13.6 into Z square upon N square. So the correct matching of P will be 5, in which it says that energy of radiation due to electronic transitions from hydrogen like atoms. So A could not be the correct one and D could not be the correct one. Now we need to check Q. So in Q option this energy is seen, and we know that this is the energy of characteristic X-rays, because if you remember that Moseley equation for K alpha line is under root of A into Z minus 1, and H nu will be this is A into Z minus 1 whole square. So H nu will be the energy of X-ray photon and characteristic X-ray photon, and it would be A into Z minus 1 whole square. So this Q option matches with 1. So the correct option will be C. So guys, this was the complete analysis of paper 1 of JEE Advanced, and I think that most of the questions were in the easy category. 3 or 4 questions were on average category, and only 2 questions were of tough category. That is also not tough. I would like to tag them as calculative ones. So very soon we'll be uploading the paper 2 analysis of JEE Advanced 2025. Thank you.